Now, to continue with our MSA, Measurement System Analysis studies, we're going to take a look at a before and after gauge analysis. And this is a case where we needed to conduct a design experiment to improve a leather skiving machine process, which is used to make leather belts. And the issue was to be able to adjust and control the skiving machine, we really needed to understand the thickness of the leather, but the leather comes in different grades and has different hardnesses. So the first thing we had to make sure is that we could measure the thickness consistently of the leather. So we set up a gauge R&R study with 3 operators. We had 10 different parts. Each operator measured each part 3 times. And this was done with a caliper type micrometer. So let's take a look at the gauge study and see how we did. So that's Stat, Quality Tools, Gauge Study, and we're going to select the Gauge R&R Study Crossed. All right, the parts that we have is in C3, the part. The operators is C1, the operator. The measurement data is in thickness, C4. We're going to do an analysis of variance. That's our method of analysis. All right, gauge info, and we're just going to call this one original gauge. Options. All right, this is everything that we want. This is the original gauge. All right, let's go ahead and run our Anova method of analysis on our gauge R&R study crossed. All right, so looking at the graphic, we can see that a lot of the variability is tied into repeatability and reproducibility, and not much of it is tied into the part. All right, and we can see that in our X bar and our R chart, we actually have some pretty wide control limits because there's a lot of variability, and we can see a lot of variation in thickness measurements by each part, and we can see that the operators don't really agree completely, and these don't track along very nicely, so this really doesn't look very good. So let's go to the session window, and we'll scroll up and take a look at our analysis of variance. And it says that yes, there is a difference between the parts, but there's also a difference between the operators, and we can't have that. All right, and that's because our p-values are 0.05 or less. Now let's scroll down to our percent contribution. All right, if we have a marginal gauge, it should be less than 9% contribution. We're at 73.6% contribution for total gauge R&R. All right, to be a good gauge, it should be less than 4%. To be an excellent gauge, it would be less than 1%. We're not going to be able to conduct a design experiment if we can't measure the leather thickness. And right now, given the condition of this particular measurement device and the system and method we're applying, it's not working. So let's go back up to our worksheet folder and take a look at the after the improvement. So the improvement was we actually welded a dime onto both sides of the caliper so that we had a wide surface so that we wouldn't get any penetration into the leather if it was really soft. And then we actually applied a spring to get the same pressure of contact when we went to make our measurements. And that was the improvement that we thought would work. So we did those changes to the gauge, and then we, once again, 10 parts, basically this is all the same leather that we had before. And so let's go through and see if we made an improvement. So Stat, Quality Tools, Gauge Study, and this will be R&R crossed. All right, the part numbers are in C3, the part. The operator C1 is the operator, and C4 is the thickness. All right, gauge info, and this is the improved gauge. And options, this is our improved gauge. And let's conduct our study and see how it looks. Oh yeah, now that's what I'm talking about. All of the variability is sitting here in part to part. There is virtually no variation in the gauge R&R, repeatability, and reproducibility. We can see that our control limits are smushed together, okay, because there's low variation. The operators look the same. They don't look any different. We can see dramatically that there is differences in the parts with very little variability about the measurements, and all of our operator and part interactions track right along nicely, almost identical. So that looks awesome. Let's take a look at the numbers, and we'll scroll up and take a look at our two-way analysis of variance, and we can see that, yes, beyond a shadow of a doubt, there is a difference between the parts. There is no difference between the operators, and we have a nice part-operator interaction, which is good to see. All of this is good. All right, let's scroll down here and look at our percent contribution. It's at 0.7. It's less than 1%. We have an excellent gauge. All right, so now with confidence, we can proceed to design the experiment, and we'll be able to have a consistent leather thickness measurement, which is part of the experimental design, to be able to make sure that we can measure the thickness to then determine the best settings to do our skiving process to make lots of belts and no scrap. All right, so that's how you conduct a gauge R&R study, okay, with continuous data, and we did this in Minitab.